Hi, my name is Sai Harshvardhan. Currently, we are working on the ICP2 from B+. Coming to this, we have an first problem is using the history data object in the source code, plot the plot the loss and accuracy for both the training and the test validation data. In this, we are going to plot the loss and the accuracy for both the training and the training and the validation data. Before that, I will just run the code. In the meanwhile, I will explain the code. Here, this is the data which is train images and test labels, and test images and test labels are taken up loaded into this, and then in the training data we are going to display the first image, and the first image is taken like a zero image of 0, and we are going to show that image, that is this image. This is the first image, and we are going to display that, and we are going to process the data and converting each image to the 24 by 28 by 28 dimensions. And in this we are going to calculate the trust we are going to reshape the data using train images and the test images. The first image we are going to reshape it, and then we are going to convert the value into the float. The size values will be converted into the float for the tested and trained data, and this will be scaled uh, using 255. Then we are going to change the labels from integers to the one hot encoding using one hot encoding. We are going to create a model called a sequential, and using dense layers we are going to add the dense layers to it. Here we have added a 512 dense layers, and we are going to calculate the output using activation softmax. In this dense layer we are going to use the activation ReLU. After that we are going to evaluate the result for the test data for the loss and the accuracy, and the same thing we will going to evaluate for the training data too. Then summarizing this data, we can give the graphs. This is the accuracy graph, which we can, the blue line represents the train data and the orange line represents the test data, and this is the model accuracy, which is increasing at a point. The test data is increasing exponentially, and even with the training data. And coming to the model loss, the model loss will be decreasing exponentially for both the training and test data. It was started with a 0.25 to ends with a 0.02 in the with the scale of 0 to 4. They just collide at 1.5. This is the model loss, and these two things were plotted using graphs. Coming to the here, we have evaluated the accuracy and the loss for the training data, that is 0.07 loss and 97% of accuracy, and for the test data, and for the training data is 0.025 and the accuracy is 0.99. Coming to the next program, it's the plot one of the images in the test data. Here we have to plot an image from in the test data, and then do inferencing to check what is the prediction of the model on that single image. We need to the model which we have created, right? With using that model, we are going to interpret whether what is the image looks like, what's the value present in the image. Coming to the next program, we are going to run the second program. Here I took the input image, which will be displayed here right now as an input, and using my model I'm going to interpret this value. Here the image which we have taken is 7. using the processing data, we are going to take that image and started to train and test using reshape, getting the train and test data using reshape function with the train images. And this value, this image value is since it is the first one, we are going to send as a parameter train dot images dot shapes of 0. And as we done before, we are going to convert it into a float, and we are going to scale it with the 255. And then we are going to create a model called sequential, and creating the dense layers with the 512 neurons. And then the same softmax and activation for used for the output. And for the activation, we have as a model for the dense layer, we have used activation as a redo. And coming to the result, we are going to predict by sending this image into the class name. This is class name is 7. Since the value represented in the image is 7, our model is successfully able to predict the value called 7, and the accuracy value is around 98%, and the loss is 0.06%. Coming to the third program, which was given, was we had used two hidden layers and relay activation. Try to change the number of hidden layers and the activation to Tana or Sigmund. See what happened. Right now, I'm going to change the activation layer as a Tana, and right now I'm closing the image. I'm going to change the activation and add the new dense layers. Before explaining, I will run this code so that we can utilize the time efficiently. uh, Here in the same way, we have trained the data with the labels, and then we are going to process the data. What the difference which we have done from the last thing to this thing is, I have added one more layer with the 600 neurons, or else we can change it to 650 720 neurons, 720 neurons with an activation of a 10 and we for the result, I have used same softmax activation and with the dense with the neurons of 10. I'm going to plot this how the accuracy changes will occur. Now for this particular data, we are going to see it in the this particular code as a result. The result is an evaluation of the test data with an accuracy, and the loss will be seen here. The loss is 0.085 and the accuracy is 0.98. 97% of the accuracy was there. There has been a change in the accuracy since we have added an extra dense layer into the after creating a model. Coming to the last program, it's a bonus point, and we are going to run the same code without scaling the images. How the accuracy changes? Without scaling, automatically the images uh, without scaling, the automatically the accuracy changes and the accuracy will be decreased a little bit. So now I'm going to run the same thing, and by commenting the before going to explain the program, I will run the program. Hmm. By Since as given in the program, to comment the scaling of a train data and the test data, I have commented the both the training data and the test data, and then I have executed the same code without adding the dense layer, which was asked in the third function, third one. With the specific of things, we can see the result how it changes. Before it, we got at 0.98. After adding a dense layer, we got a 0.97. And here, right, when we have added, when we have removed, thank you, thank you. Mm. Mm. The accuracy value changed as 0.96. It was decreased a little bit. Thank you. This is the final result of the complete ICP. Thank you.